Hello, I hope you're doing well. I'm just working on our lighting here in the studio, but I want to share briefly about the counting to calculus sequence. Whenever we meet with students, one of the first questions we need to ask is, where are you in the journey from counting to calculus, right? Students should be able to track their progress. I mean, how cool would that be that every kid in America knows exactly how far they are from calculus? Maybe or how many skills they've mastered on the way to calculus, the exact skills. So that if you were to ask them, hey, what are you doing on Friday night? How are your skills looking? And what do you want to work on if you have an hour to spare? You might say, you know what? I've been struggling with polynomial addition. So I'm going to work on that on Friday night. And I'm going to move up and level up in my journey to calculus. Let's standardize the process. There's no reason why we couldn't do that. Why? Because we know the story, or at least a little bit of the story of calculus, right? This is called the origins of the infinitesimal calculus, right? That's a big word. Kepler, Galileo, Newton, Leibniz, all these people made an impact in this issue of what calculus would become. Ultimately, Newton and Leibniz are the main names we talk about. But I think every student should know where they are as they're approaching what derivatives are and integrals. This is the era. I call it the era of the space, quantum, and AI. I actually have a few books here to show you for that. So basically, imagine our tagline, right? One of the ways I would put our tagline is, math as it should be mastered in the AI, quantum, and space age. AI, quantum, and space age. The time has come for us to make sure that we understand math in the context of more than just math. We need to understand math in the context of how it applies to chemistry and physics. There's a company called Wolfram, and they make Wolfram Alpha, Mathematica. And when you look at some of the story of the CEO of that company, you would notice that his background is physics, right? But he's in computer science and physics and math, and it's all coming together. And that's part of what Counting to Calculus is seeking to do, is to give the cutting edge response to curriculum development that follows up with AI speed. Almost every week we hear another update with the AI world, right? Now, I'm not saying that we should have our students in the classroom be confused every day on what they should be learning, where they're at. But here's the key. What if we can show our students a clear roadmap from counting to calculus? I've made a list. I've made an Excel document. I can email to you. You can look at that list and you could help your students change it from, I've mastered it, would be green. Red would be, I have no idea. Yellow would be, I'm making progress, right? We're going to automate a lot of these in our apps that are built later on. But right now, we're using an Excel document. Everybody knows the journey to calculus, 245 or 248 topics, somewhere in there. We know the exact list of topics, the exact list of skills. We have books like OpenStax and other resources to help us navigate the way. Every student, when we meet with them weekly, we're checking in. How is it going in your journey? Now, one thing that'll be cool with the app, and then I'll say one more thing interesting for tutors to keep in mind. But one thing that'll be cool with the app is, how cool would it be that when you log on the app, it'll ask you, what is your goal? Do you want to get to calculus 1, calculus 2, calculus 3, differential equations? Do you want the full thing? Or do you just want to get to calculus 1, which I call the lowest bar, but at least you've gotten to calculus. And the thing is, I'm not saying that people should do calculus and not have resources like open book tests and so on. Like, let's say somebody really is struggling. Like maybe there's a disability or a concern and they can't do calculus with their books closed. That's fine as long as they get there, right? But everybody gets there. But those who want to go further, they put it in the app, and then the app is tracking your progress. How far are you to get to your destination, right? Computer science, again, is a big part of this curriculum. And what makes us different is we want to teach computer science along with mathematics. So everybody should be able to track where they're going. Now, here's what's cool. If you have a school, if your school wants to learn mathematics and help students master math in the AI and space and quantum age, like quantum computing and things like that, then what of this idea? We have a curriculum that you can follow, a curriculum framework. It has workbooks, a lot of which just follow the OpenStax textbooks. So you have OpenStax textbooks, which have been used by millions of students. You have workbooks, so your students are learning study skills. You have the history of mathematics that we bring into the equation, encouraging students to learn about Newton and Euler and Gauss, right? and Euclid. We want those people to be like the standards that the kids are learning about. Who are these people, right, that change the world? So you have the workbooks, you have the textbooks, you have the people they're learning about in history. You have an online portal with videos that they can use. And we give your school all of that support and the tutors for your school to support your students. Your teachers are teaching, and they know that their students have tutors later that can use those materials. Like, how cool would it be if teachers and tutors are on the same page on the content that is being learned and the pace with which it's being learned? Okay. Now, I know that there's some textbook companies that have like an online portal or like maybe you have a big textbook company, they sell you the textbooks, and they might have a portal for teachers to log in and do certain things. But how cool would it be if the textbooks that we sell to you, along with the workbooks, along with the teacher training, align with the tutors that we also can provide to your school? That's what we are seeking to do with Counter to Calculus. We're giving you everything your students will need, so that if the traditional classroom of maybe 15 to 20 kids, your students feel like they're still struggling, they just slide into tutoring after school, and they get support from tutors that have been trained by the same people that trained the teachers that are teaching them, but now they're getting tutored on a one-on-one. And that tutor now sends a message to the teacher about how the tutoring session went and what you might be dealing with. And the tutor also sends a message to your parent. How cool would that be? And on top of that, eventually, this is the next level, okay? When the students walk in on a Monday morning and we give a quick diagnostic assessment, we can then place them in the appropriate math class that they need to be in, or the appropriate section they need to be working on, and we can group them into those sections, give them the tools they need to keep pushing forward. Let's reward the students who maybe over the weekend have worked on certain concepts. They show up in the morning. They shouldn't have to sit down in a lecture and listen to something they already know how to do, because we already know where they're headed in this journey. This gamification might cause some students to actually begin to put in the extra work, because they want to like level up. Like, I'll see you on Monday, and I'll be on fractions and polynomial addition. I'll be on rational expressions. How cool would that be? That's now the challenge. So then in the summer, some kids might say, hey, I'm going to work on my Algebra 1 and 2 sequence over the summer. I'm going to finish both Algebra 1 and 2 in 3 months using Counter to Calculus framework with all the tutors they provide. And I'm going to test out of the class so that in the fall, I'm in pre-calculus or geometry. And we've rewarded them for that extra work they put in. And they don't feel like they've done the work. They come back and then we tell them, sit down, we're going to teach you the same thing that you were doing last year. I don't think that's fair to the student. What do you think, right? But then one more thing. How cool would it be where the students, again, are rewarded for putting in the extra work or effort, and then we maybe give them opportunities to tutor other kids that are going on the journey. Like, we all know where we're going. That's the cool thing. We all know we're going to calculus. Now, ideally, I would love to see calculus, linear algebra, discrete mathematics, and computer science, right? I don't want to just get kids to calculus. Linear algebra is becoming gold. Like, that's AI is built on that. That's where I want to see our tutors train students to. So schools, we can provide you with textbooks from OpenStax. We can provide you with workbooks. We could provide you with teacher training. We could provide you with any curriculum development work you need. We could provide you with tutors after school. We could provide you with tutoring during the summer. We could give your students a full experience of mathematical learning like never before, so that they don't have limitations in what STEM careers they can go into. Because there's a high return on investment if you go into engineering. There's a high return on investment if you go into places like computer science. But we also teach entrepreneurship within the context of our curriculum, whereby they have a project to work on and they can tackle that project and use all the mathematical skills that meet up to the level that they're working on. So these projects are stationed at specific levels. And as the kids have learned about basic fraction addition and so on, now they have a project that would focus on just using fractions, and everybody can have fun, which leads me to the last major thing I want to say. What happens when 10 kids in a classroom are in 10 different spots and you're supposed to teach them a lesson on the board? How do you navigate the fact that people are all over the place? Here's the answer: 2 ways. Number one, we could teach them a historical perspective on something, such as Fermat's last theorem. So imagine in the math classroom, you say, hey, everybody, we're going to talk about Fermat's last theorem. And what will happen there is that the kids will learn the beauty of the story of Fermat's last theorem. They will learn about Sir Andrew Wiles. They will learn about the people that were wrestling to solve it for 200 years. That will make the whole class unify and understanding the nature of mathematical progress. That's number one. We can use math history as a level ground and then give them a chance to split into their different cohorts or different small groups working on different math concepts. Because you'd never want your kids to be frustrated because they don't have the prerequisite skills to keep moving forward. So we need to work on that. But number two, we need to look at applications of mathematics. Hey, we're going to build a rocket, everybody, right? And now the kids can learn about rockets and use the math skills that meet them where they're at. Rockets, the beautiful thing about rockets is you can talk about rockets and focus on calculus. You can talk about rockets and focus on chemistry. You can talk about rockets and focus on physics. You can talk about rockets and focus on business and entrepreneurship and economics. Rockets as a starting point can open doors to many aspects of learning. And sometimes maybe you'll have a classroom of kids who are just so fascinated with physics, so you use the rocket physics module or the rocket chemistry module. If you have all these kids who are like, we want to learn about fuels and oxygen, great time to talk about rockets from a chemistry perspective. Okay, that's a lot to chew on. Math education is due for an upgrade. Pre-algebra and all these courses here, we can help students to learn and grow, including career preparation, linear algebra, and so on and so forth. I look forward to sharing more in this journey, in this tutoring and teacher training program. But I just wanted to give you some more insights into the things that are going through my mind. Please email me if you want to get the list of concepts from counting to calculus. And then OpenStax has all those textbooks. The key 3 textbooks for OpenStax are the pre-algebra, the elementary algebra, and the pre-calculus. If you do those 3 books, you're actually ready for calculus. Now, geometry can be done alongside those 3. That's how Nigeria does some of their math. You do multiple math courses at the same time. And now we're learning that that's actually a good skill when it comes to learning. So for example, if you want to learn one language, you can learn another language alongside that language, and that helps your brain. There's this idea of ultra learning and super learning. And that's part of what we're seeing from that research. There are great books on study skills. Barbara Oakley, Learn Like a Pro, great resource. I look forward to talking more on learning and study skills, which is part of this whole equation. We know where the kids are going. We have the 245 topics. Let every student have their copy and let them keep changing it to green as they master the concept. We're going to gamify it and put it out there and help people master math, which opens doors for them into many fields. I think that's it for now. I know there's a lot more I could share, but thanks for watching. Look forward to talking to you all soon. Have a blessed day.